Welcome to AI Frontiers, where we explore the cutting-edge developments shaping our technological future. Today we're diving into the world of computer science robotics through 14 groundbreaking research papers from November 7, 2025. These discoveries are democratizing advanced robotics technology and showcasing revolutionary vision-language-action integration breakthroughs that are transforming how we think about human-robot collaboration. Picture this. A robot that costs less than your monthly grocery bill outperforming million-dollar laboratory systems, or a soft-bodied flying machine that can survive head-on collisions while performing aerial acrobatics. We're witnessing the most dramatic transformation in robotics since the first industrial assembly line. These 14 papers are literally rewriting the rules of robot capabilities, breaking down the barriers that have kept advanced robotics locked away in expensive laboratories for decades. Today's journey takes us through cutting-edge computer science robotics developments that are breaking down traditional barriers to advanced robotics access. We'll explore the revolutionary fusion of vision, language, and action that's making robots more intuitive than ever before. We'll uncover the biological secrets inspiring a new generation of resilient, adaptable machines. By the end of our exploration, you'll understand why we're standing at the threshold of a robotics transformation that could reshape everything from manufacturing and healthcare to space exploration and daily life. Think of computer science robotics as the ultimate interdisciplinary orchestra. Mechanical engineers compose the physical movements, while electrical engineers conduct the sensory symphony. Computer scientists write the intelligence score, and artificial intelligence provides the improvisation that brings it all alive. This field represents one of humanity's most ambitious endeavors, creating machines that can perceive, think, and act in our complex, unpredictable world. What makes this moment extraordinary is the convergence of multiple technological advances flowing together into a torrent of innovation. The first revolutionary theme reshaping robotics is vision-language-action integration, or VLA models. Imagine trying to teach someone to cook without being able to show them ingredients, explain the recipe, or demonstrate techniques. That's been the challenge with traditional robotics, until now. VLA models are like giving robots the ability to see the kitchen, understand your recipe instructions, and translate that understanding into precise hand movements. Chopra and colleagues' EverydayVLA democratizes this technology, while TwinVLA shows how modular composition can outperform monolithic approaches. These systems map visual inputs and language instructions directly to robot actions with unprecedented sophistication, making advanced reasoning accessible to researchers worldwide. The second theme revolutionizing robotics is cost-effective and accessible design. For decades, advanced robotics has been like owning a Formula One race car when most people needed a reliable bicycle. The EverydayVLA project exemplifies this transformation by demonstrating a 6-degree of freedom manipulator assembled for under $300 while matching the performance of systems costing thousands. This isn't just about making robots cheaper, it's about democratizing access to advanced robotics research and development, potentially unleashing innovation from unexpected quarters of the world, where budget constraints previously prevented participation. Neo-inspired design and soft robotics represents our third major theme, and it's perhaps the most elegant. Nature has been running the ultimate robotics research and development program for millions of years, and we're finally learning to read her blueprints. The FlexiQuad project creates soft-frame quadrotors inspired by biological organisms, achieving exceptional agility with collision resilience combined in ways engineers previously thought impossible. These systems can squeeze through tight spaces like living organisms while maintaining remarkable performance characteristics. By reading nature's blueprints, researchers are creating robust robot designs that achieve engineering trade-offs once considered impossible. Now let's explore the key breakthrough stories that are reshaping the entire robotics landscape. The most significant finding demonstrates that $300 robots can outperform expensive systems by 49% in familiar environments. TwinVLA's modular approach beats traditional monolithic training methods by cleverly composing multiple specialized components. FlexiQuad achieves speeds exceeding 80 km per hour while surviving frontal collisions. VLAD-Grasp leverages foundation models without requiring task-specific training, while LightVLA enables sophisticated real-time reasoning on resource-constrained mobile platforms. These aren't just incremental improvements, they represent fundamental shifts in how we approach robotic system design. Today's featured paper comes from Samarth Chopra and colleagues, whose EverydayVLA project may be the most democratically impactful contribution to robotics in recent years. Their work addresses the prohibitive cost barriers that have fundamentally limited advanced robotic system adoption for decades. They achieved something remarkable, demonstrating that a 6-degree of freedom manipulator built under a $300 budget constraint could match state-of-the-art performance. Their unified architecture eliminates computational overhead by jointly outputting discrete and continuous actions, while an adaptive horizon ensemble manages motion uncertainty through intelligent replanning. This represents an order-of-magnitude cost reduction without performance loss. The methodology behind EverydayVLA showcases true innovation under constraints. The joint, discrete, continuous action output architecture streamlines computation while maintaining sophisticated reasoning capabilities. The system uses readily available components that require no specialized equipment for assembly, making advanced robotics accessible to virtually anyone. When uncertainty exceeds safe thresholds, on-the-fly replanning ensures reliable operation even in challenging environments. On the Libero benchmark, the system matches expensive system performance while achieving 49% improvement in familiar environments and 35% improvement in completely novel scenarios. This demonstrates that democratization doesn't require compromising capability. The global impact of EverydayVLA extends far beyond technical achievements. Universities can now provide hands-on robotics experience affordably, enabling students who might never have encountered advanced systems to engage directly with cutting-edge technology. Developing regions can participate in cutting-edge research without traditional infrastructure barriers. Individual researchers can explore novel applications without institutional backing, while home automation and assistive technologies become feasible for ordinary consumers. This represents a fundamental philosophy shift from exclusive to inclusive robotics, where creativity and insight matter more than budget size. The democratization could accelerate innovation by enabling a much broader global community to contribute. Looking toward the future, these convergent technologies are taking root like seeds carried by wind to fertile soil. Picture factory workers giving natural language instructions to robotic assistants that understand context and adapt to changing conditions. Imagine rescue robots making autonomous decisions in disaster zones while maintaining coordination with human teams. Envision elderly individuals receiving assistance from affordable robotic companions that understand their needs and daily routines. Bio-inspired machines will be more resilient and energy efficient than anything we've built before, while edge computing enables truly autonomous operation without dependence on cloud connectivity or high-speed internet infrastructure. We're witnessing robotics transition from laboratory curiosity to everyday utility, much like how mobile computing evolved from expensive luxury to essential tool. Chopra and colleagues, along with other researchers we've explored today, are democratizing advanced capabilities that were once confined to well-funded institutions. Bio-inspired designs are creating resilient, adaptable machines that work harmoniously with natural environments and human spaces. Human-robot partnerships are becoming intuitive and accessible, with robots serving as collaborators rather than replacements. This revolution is happening now through breakthrough research that's redefining what's possible when advanced robotics becomes as accessible as personal computing. Full transparency about our research synthesis process. This analysis was created using GPT and Claude Sonnet 4 models to process and synthesize the 14 research papers we've discussed today. Text-to-speech synthesis is powered by Deepgram technology, while image generation utilizes OpenAI systems. All content has been reviewed by a human robotics expert to ensure technical accuracy and appropriate context. While we strive for comprehensive coverage, we acknowledge that some oversights may exist in our analysis. We encourage listeners to explore the original papers for complete technical details and to form their own conclusions about these important developments. Thank you for joining me on this exploration of AI frontiers that are reshaping our world, one breakthrough at a time. Subscribe to AI Frontiers for weekly research synthesis that keeps you informed about the latest developments. Explore the technical details in the referenced papers we've discussed today. Share your insights using the hashtag AI Frontiers Robotics and engage with these breakthrough discoveries that are shaping our future. Join the conversation about human-robot collaboration and consider how these innovations might apply to challenges in your own field or community. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archivepreprinserver.org, content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archivepreprinserver.org.